Hi everyone, welcome to my channel. In this video, we are going to discuss composite functions. A composite function is a function that depends on another function. In a composite function, you substitute one function into another function. Now, for example, this f of g of x, this is an example of a composite function, and it is formed when g of x is substituted into for x in the first function f of x. Now, what does it mean? Let me show you by using examples. Let's say you have this function f of x, and this equals to 2x plus 3. And you have another function g of x, and this equals to negative x squared plus 5. So if you want to find the composite function f of g of x, it means that you are going to substitute x equals to this thing to the first function, that is f of x. That means g of x is going to act as the value of x for this function 2x plus 3. Now this equals to 2, and in the place of x, I'm going to write this whole function instead of one number. So I'm going to write negative x squared plus 5 and then plus 3 outside. So I'm going to have negative 2x squared plus 10 plus 3, and this will give me negative 2x squared plus 13. This is how you can find a composite function. Now, what if I ask you to find g of f of x by using the same examples? So everything is going to be the same. The idea is going to be the same, but it just means that f of x is going to act as the value of x for this function now. So f of x is going to be my x for g of x, that is this function. So this equals to negative, and for x, I'm going to write this whole thing, which is 2x plus 3. Now note something, that I'm not including this negative inside, because if you write it like this, negative x squared, it doesn't mean that negative x in bracket to the power of 2. It's not that. It's just in front. So I'm going to keep it over here. So this is going to be squared plus 5, and let's break this down. I have negative, and then inside 2x whole squared will give you 4x squared plus, I'm using this formula and I already explained it to you. This equals to a squared plus 2ab plus b squared. So 2x whole square means 4x whole square, 4x to the power of 2 plus 2 times 3 times 2x. That will give me 12x plus b squared, which is 3 squared, that is 9, plus 5. Now I'm going to remove the bracket, and note that the signs are going to change, because when you have a negative sign in front of a bracket and you open the bracket, all the signs changes. So negative and positive will give you negative 4x squared, negative 12x, negative 9, and then positive 5. And if you simplify, this will give you negative 4x squared minus 12x and minus 4. So you can see that if you write it in the other way, like opposite, so you have to take this as the value of x for the first function. Let me show you another example. Let's say I have f of x equals to negative 4x plus 9 this time, and my g of x, now it doesn't matter what letter you use, it could be anything. So this equals to 2x minus 7. If I want to find out f of g of x, I'm going to take this thing and substitute it into this for x. So I'm going to write negative 4, and inside the bracket, I'm going to write 2x minus 7, and I have 9 outside. This equals to negative 8x plus 28, and then plus 9. This will give you negative 8x plus 37. What if I ask you to find g of f of x now? It just means you're going to use this as the value of x for the first function, which is g of x. So I'm going to write 2, and instead of x, I'm going to write negative 4x plus 9, and then you have negative 7 outside. So if you open the brackets, you are going to have negative 8x plus 18 minus 7, and this equals to negative 8x plus 11. Okay, now you can see that f of g of x and g of f of x, they are never the same. Okay, this is not the same. Same goes for this one. F of g of x and g of f of x is not the same. It's negative 8x plus 37 and this is negative 8x plus 11. Now for this example, what if I ask you to find this f of g of 1 for the same example? So for this kind of equation, it just means it's the same thing as f of g of x, which is our this function, but for x, now you have a value, which is 1. So I'm going to substitute x equals to 1 plus 37, and this will give me negative 8 plus 37, and this equals to 29. Okay? Now, when working with a composite function, such as f of g of x, we always start with the innermost function and then work outwards. So if you have something like this, sometimes you will also find the questions like this, g of h of x. Now it's the same thing as g of h of x. This just means this will act as the value of x for the first function, which is g. Now also, if you have two composite functions, like if you have f of g of x and it equals to x, and for the same example, if you have g of f of x and that equals to x as well, then you can say that these two functions are inverses of each other. I explained the inverse function in my previous video, so if you don't know what I'm talking about, watch that video first and then come back to this one. So what does it mean? How can you prove if two functions are inverses of each other? Let's say if you have f of x and this equals to 2x plus 3 and your g of x equals to x minus 3 over 2, and you can find f of g of x by substituting this thing inside that. So I'm going to write 2, and instead of x, I'm going to write x minus 3 over 2, and then you have the 3 outside. So you have 2 over here, you have 2 over there, you can cancel the 2's out. As a result, you will just have x minus 3 plus 3. And negative 3 plus 3 gets cancelled out, it just equals to x. So it's already true for this. Now let's look at this one, g of f of x. So if I use f of x as the value of x for this function, what happens? So for x, I'm going to write 2x plus 3 minus 3, as you have it outside, over 2. This equals to 2x plus 3 minus 3 over 2. 3 and 3 gets cancelled out. You have 2x over 2. You can also cancel out the 2's, and as a result, you will just have x, which also satisfies this condition. So you can see that from this example, f of g of x equals to x, and g of f of x is also equal to x. So you can say that these two functions, f of x and g of x, they are inverses of each other. Okay, so that will be all for today. If you like my videos, then don't forget to subscribe. See you next time. Thank you.